Okay, let's move on. This video is going to start with problem 30. Now, when you're asked to solve a quadratic is equal to a 0, or if any polynomial equation is equal to 0, you're being asked to find what are the zeros. And this is one way you could be asked to find that. Now, one way you could do is look up and see where the x-intercepts are on the graph, because x-intercepts are zeros. Another way you can solve this is to factor it. Since it's x squared by itself, are there two numbers that multiply together to give you 4, but at the same time add up together to give you 5? And yes, there are, 4 and 1. So I can factor this as x plus 4 times x plus 1. And when you do that, you can see what values of x will make this equal to 0. So what are the zeros? We can see if x is -4, that will make this parenthesis 0, so it makes the whole product 0. And if x is equal to -1, that will make this parenthesis 0, which makes everything 0. So the solutions to this are x equals -4 and -1. Okay, so the answer to that one is going to be C. All right, now when I get to number 31, I can't solve that the same way I did this one because I'm not going to be able to factor that. If I try and use that trick that I did for number 30, I'm not going to get anywhere with that. Two numbers that multiply together to give you -6, but add up together at the same time to give you 4, and we can't find them. So when that happens, you have to use the quadratic formula. So if I use quadratic formula, A is going to be 1, B is going to be 4, and C is going to be -6. And so the solution to this, the zeros are going to be minus B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So this is going to be -4 plus or minus the square root of 16, and then these negative signs cancel. So 16 plus 24 all over 2. And 16 and 24 is 40. All right, now don't ruin it by saying, oh, yeah, 40 divided by 2 is 20, and I'm going to get square root of 20, because that doesn't work at all. That's not correct. I'm just checking the answers there. All right. Well, first of all, we have something positive in here. Our discriminant is positive, so we're going to have two real solutions. We're not going to have complex solutions, so there's not going to be an I anywhere involved. So you can, for this one, you can rule out you can rule out B and C because they have I's involved. Okay. So also 40 is not a perfect square, but I can rewrite 40 as 4 times 10. So I can rewrite the square root of 40 as the square root of 4 times the square root of 10. And I can rewrite the square root of 40 as 2, because square root of 4 is 2, times square root of 10. So that's what I'm going to do here. So instead of square root of 40, I'm going to have 2 times the square root of 10. And now you can split it up if you want to. So that's going, since we just have a single value in the denominator, that's going to be -4 over 2 plus or minus 2 times square root of 10 over 2. And -4 over 2 is equal to -2, then plus or minus, and these 2's will cancel, and we have the square root of 10. So I'll get -2 plus or minus the square root of 10. All right, so -2, okay, so they didn't use the plus or minus symbol. So that means you can either have -2 plus the square root of 10 or -2 minus the square root of 10. Okay. And here we go, -2 plus the square root of 10 and -2 minus the square root of 10. So the answer to 31 would be D. All right, 32, they want you to solve that equation for C. You want to get C by itself, and then as you can see on the left-hand side. So the first thing we need to do is to divide both sides by M. And then the next thing I need to do is to take square roots of both sides. Now, when you take square roots of both sides, you get plus or minus. So here I'm going to have C is equal to plus or minus the square root of E over M. And now I can swap this. All right, now let's have a look at what our selections are. All right, so that's the one I've got there, and that is correct. So that would be B. Okay, so now let's look at number 33. F of x is a quadratic function with integer coefficients, and the discriminant is 16. So you'll be taking an online final, and so you'll be getting different types. You'll be getting every type of that. So let's suppose, well, first of all, the discriminant is b squared minus 4ac. Okay, that's what's underneath the square root symbol. So if you've got minus b plus or minus the square root of b squared minus 4ac all over 2 times a, then the discriminant is what's inside there. Okay. So we've been told that the discriminant is 16. So if the discriminant is 16, then you're going to have negative b plus or minus the square root of 16 all over 2 times a, but the square root of 16 is 4. So you'll have two answers, minus b plus 4 over 2a and minus b minus 4 over 2a. So we're going to have two distinct rational zeros. Okay, two distinct rational answers. A rational answer is a rational number is one that can be written as a fraction, and we can see that these both can be written as fractions. So there will be two rational zeros. So the answer to that one is C. Now, what if we had been told that the discriminant is negative 16? Then we would have had that, which would have been negative b plus or minus the square root of 16 times I over 2a, which is negative b plus or minus 4i over 2a. And we would have gotten two non-trivial complex numbers. There would have been two non-real complex zeros. Okay. All right, so what if we had that the discriminant was 0? If the discriminant is 0, then the zeros would have been negative b plus or minus the square root of 0 over 2a. And the square root of 0 is 0. So I would have had one rational 0, one answer, and it would have been a rational number. One rational 0. Okay. Two irrational real zeros, that would have been if the discriminant was a positive number, but unlike 16, it was not a perfect square. So I don't know if this discriminant is 2 then I would have had negative b plus or minus the square root of 2 all over 2a. And the square root of 2 is irrational. So I would have had 2 irrational real zeros, but they would have been irrational. Okay, so 2 irrational real zeros. Okay, now we have a right triangle. Okay. The hypotenuse has a length of 13, and one of the lengths has a length of 5. Okay. So I have a right triangle. Now it doesn't matter how I draw it. I'm going to draw it this way. So if I have a right triangle, the hypotenuse is the leg that's just the opposite of the right angle. And we've been told the hypotenuse is 13. And one of the legs has a length of 5. Okay, so I can assign either one of these a length of 5. How long is the other leg? So if I call that x, they want to know, find x. So the Pythagorean theorem says that the hypotenuse squared is equal to the sum of squares of the other two legs. So I'll have 5 squared plus x squared. And so to get x, I need to, well, I can do these. 13 squared is 169. And so now I need to solve for x. So subtract 25 from both sides. So I get 144 is equal to x squared. And now take square roots of both sides. When you take square roots of both sides, you're going to get plus or minus. So we have plus or minus the square root of 144, which is 12. But we're talking about the length of a side of a triangle, so we have to choose the positive one. It doesn't make any sense for a length of the side of a triangle to be negative 12. So the answer there is positive 12. So the answer is B. All right, now, when they ask you about shifted form, well, they're just asking you which one of these is the same equation as that, because shifted form is just a different way of writing that. And so you really only need to work out which of these has the same equation. So let's look at the first one. X plus 3 all squared, that's going to be x plus 3 times x plus 3, and then plus 2. So if I FOIL this, I'm going to have x squared, and then plus 3x again, and then plus 9, and plus 2, which is going to give me 9 plus 2 is plus 11. And that does not match, and it has to match every term. It doesn't match the constant, so it's not going to be A. Let's see what happens here for B. That's going to be x minus 3 times x minus 3 and minus 7. So I'm going to have x squared, and then minus 3x and minus 3x, and then plus 9 and minus 7. But as you can see, this is going to combine to give me 2, but I have minus 6x, and this is a plus 6x, so it's not going to be that one. What about selection C? That's going to be x plus 3 times x plus 3 minus 7. So I'm going to have x squared plus 3x plus 3x, and 3 times 3 is plus 9 minus 7, and that's going to be plus 2, and this one matches. So they're the same. So the answer is C. Which of these quadratic functions has the vertex 5, 2? Okay. Well, you can certainly look at all of these in your graphing calculator and see which has the vertex 5, 2. I mean, where is 5, 2? It's here. And we can see which one's going to have that vertex. So just clear out what we have in here. So I could do x plus 5 squared minus 2. And then look at it on zoom 6. And there's the vertex there, and that is not where 5, 2 is. So that's the point 5, 2 here. So it's not that one. So come back up here, and I'm just going to change this, put my cursor over it, and then put minus, and just press graph. Okay, now that vertex is here, which is in this second quadrant, so it's somewhere down here. So it's not going to be 5, 2. So press y equals, and now I just have to scroll over and change that to a +2 for my most recent formula, and press graph. Okay, now that's looking nice. 5, 2 is my vertex, and I can even check second graph. We can see 5, 2 is a point on that graph. So I'm done. It'll be selection C. All right, what is the vertex of this quadratic function? Well, when it's in standard form like this, the vertex is equal to, well, the x-coordinate is the negative of b over 2a, and the y-coordinate is f evaluated at negative b over 2a. So let's see what negative b over 2a is. So here we have a is 2, b is 4. Okay, and so negative b over 2a is going to be the negative of 4 over 2 times 2, which is negative 1. Okay, so my x-coordinate is going to be negative 1, and my y-coordinate is going to be f evaluated at negative 1. And what is f evaluated at negative 1? Well, f evaluated at negative 1, everywhere there's an x, you replace it with negative 1 in parentheses. So 2 times negative 1 all squared plus 4 times negative 1 minus 1. So the negative 1 squared is positive 1 times 2 will give me 2, then minus 4, and then minus 1. And minus 4 minus 1 is negative 5. And so my y-coordinate is going to be negative 3. Okay, and so we can see that. That will be it. And I could graph that and look at that. I mean, where is negative 1 comma negative 3 going to be? So my vertex is going to be there for this one. And let's have a look at it in the graph. So I'm going to press y equals. I'm going to clear that out. And I'm going to do 2x squared plus 4x minus 1. And then I'm going to just press graph. And we can see there is the vertex. And that matches up with the coordinates negative 1 comma negative 3. So the answer to that one is B. Okay, number 38. Let's solve this inequality. Okay. Well, we can certainly see what the zeros are. So when it's written like that, where is this equal to 0? Well, it's equal to 0 at negative 3, and it's also equal to 0 at positive 5. So there will be x-intercepts at negative 3 and positive 5. Okay. And now let's look at the graph of this. So let's come here and clear that out, and then put in x plus 3 times x minus 5. And let's just see what the graph is like. Okay, so what we have is, it's doing something like that. Okay. All right, now let's get to the question at hand. And you could be asked very different versions of this, depending on what the arrow says. All right, now, this is the graph. All right, so where is this greater than or equal to 0. It's greater than or equal to 0 when it's on and above the x-axis. So because of the symbol, this happens when it's on or above the x-axis. Now, where does that happen? It's on at the x-intercepts. So because of the symbol, we include the x-intercepts. And then where's the graph above? It's above for this part here, and it's above for that part there. So that is where it is on or above. Now, how do you describe that? You describe where that happens using the x-axis. So here's the x-axis, and coming in from left to right, so this is going to keep going like that forever. I don't have a left limit, but we keep going until we reach -3, and -3 is included because of this symbol here. And then there's a gap. And we pick it up again at 5. It is on at 5, so it's allowed. And then it just keeps going like this forever, and there won't be a right limit to our x values. So the answer to this one is going to be A. Okay. Now, this is randomly generated. So what if you had gotten the question, where does that happen? Okay. Well, we have the same picture. Not the same picture. But now, if this is the symbol, we only want where is it above, strictly above the x-axis. Where does that happen? And it does not happen at the x-intercepts because it's on the x-axis. So if the symbol is just that, we want to know where is it above. So we do not include these, and it's strictly above for these values. And so if I'm using the x-axis to tell where this happens when my x values coming in from the left, there's no limit, but go up to and do not include -3. And then there's a gap, and we pick it up again, but we do not include 5, and then we keep going forever. So if that had been the strictly greater than symbol, you would have chosen selection B. Now, what if the question had been, when does this happen? We'd have the same picture. Same picture. But the answer to this is you're being asked, where is the graph strictly below? Below the x-axis. And we can see right here, it's on. And so we do not include that. But we can see it's below here. And then we come up at 5, it is on. So we do not include the 5. Now, what I've done in blue is the answer to this, but how do you describe it? Well, you use the x-axis to tell where this happens. So this happens when my x values are between -3, we do not include -3, and +5, and we do not include +5. So if that had been the symbol for the arrow, that would have been the answer you chose. And then if the arrow had done this, where is it less than or equal to, then the graph would have been, where is the graph on or below? And then we would have included these because it's on there. And then we use the x-axis to describe where this happens. We start at and include -3 and go up to and include 5. So if the arrow had been this, we would have done that. You're taking an online test. It will be randomly generated. It will be one of those arrows, that 4 cases that I just showed you. And then 39, you've been told to solve this inequality. Okay. So where does this happen? Okay. This happens whenever the graph of x squared plus 1 is below the x-axis. Okay, and so let's look at x squared plus 1. That is never below the x-axis. So that never happens. And so there's no solution to that. Okay, so if they had wanted to know where does that happen? That happens whenever the graph is above the x-axis. And we can see that the graph of that is always above the x-axis. So it happens at every x value. So the answer would have been, well, any real number. Okay. So if that arrow had been turned the other way, we would have gotten that other answer. Okay, so I'm going to stop there, and I'll do 40 through 50 on the next video. So I'm going to stop this video here.